One of the most iconic buildings on campus, or at least it's used a lot in advertising promos for Waterloo Engineering, is E5. Engineering 5, so named because it's the 5th engineering building, not because someone had an excess of creativity. So I want to go walk up and take a look at some of these details that we can see on this building, because it is actually highly representative of a modern curtain wall building, and we'll talk about what that means. Curtain walls can be defined as lightweight building enclosures that are generally made of glass and metal, or be more precisely aluminum, and sometimes they have infill panels that are stone or some other product. So this is what they look like close up, and they've become very popular since the Second World War, and it's a really clear example of where we have completely decoupled the enclosure function from the support function. Through these windows, you will be able to see that there will be columns and a structural system, but the actual aluminum here is a pure enclosure function. It takes lateral loads, wind loads, earthquake loads, and transfers them to the superstructure. Now, this one happens to be a floor-to-ceiling glass solution, which is common, I think, mostly because it makes it's sort of a lazy design solution. Is, well, we'll just make it all glass. You can see you end up with some odd scenarios where at the base of the wall you actually have like a trough on the inside between the heating unit and the glass. It doesn't actually do anything to have glass there except increase costs of heating and cooling, and that tunnel there actually collects dirt and so on. The reason there's a heating unit in front of these, as you'll see in front of almost all modern curtain walls, is that modern curtain walls have horrible thermal performance, and as a consequence they need to have heat delivered right at the base of the wall to offset all the heat that's lost. So here, through the window, you can see the structural concrete column, the structural system, which was obviously built before. And also here, you'll notice through these windows, you can see that there are shelving and a computer monitor and the cables, and all of that space is hidden. It's not actually useful to have glass there. And again, remembering glass loses heat and gains heat in the summer in ways that mean that we need to spend more energy to provide a comfortable interior space. Another thing that affects all buildings and is very clear in curtain wall buildings is how do we transition between the above grade part of the building and the below grade part of the building. In this building, they've done a kind of an, typical but nice and neat way of doing it. The stuff below the ground, you can see here, these are fiber cement panels. And that then moves into a crushed stone or river rock, depending on your design choice, to break up the rain and also not require plants right up against the building, because those plants up against the building will often damage the enclosure. So here they've managed to keep the plants away from the building, and they still have the desired aesthetic effect, but it's actually a very practical solution. But it does require a separate type of a system at the base to manage this type of transition, and it occurs in essentially all kinds of buildings. So here we are at a different part of the same E5 building, and you can see a little bit more about the details of the aluminum frame here. That is a gasket, and all curtain walls, all windows have to separate the glass from the harder metal, or you will end up with a failure of the glass. So that has to be something gushy, soft, something like a sealant or an extruded gasket in the form of neoprene, EDPDM, and silicone are the obvious choices. And you can see here that in this part of the building, the base detail is actually much less. There's only about 15 centimeters, but that 15 centimeters still needs to be dealt with. And so when we look at the base here, you'll see that's a cement board that had to be installed to make that transition from the grade and the plantings or the pavement to the building. And that's an important detail that always has to be thought through in a building.